Java, an introduction. What is Java? Java is a programming language. It is object oriented. It is platform independent. That means you can write this once and run anywhere in any operating system. The syntax is similar to C++, generally used in networking programs. Object-oriented programming involves using objects to execute a given task. The objects are created from classes which have data structures called fields and operations on them through methods. A comparison would be a television set, which is an object to watch a video program. All we have to do is to switch it on and change the channel through a remote control. All the circuits and electronic devices involved are hidden or encapsulated within the TV set. Object-oriented programming in Java. An object of car is created and move is called when we say new car. Car inherits from vehicle. That is the reason we have vehicle V is equal to new car. Features. In Java, there is automatic type checking. In the sense, the type of the variables are checked automatically. Automatic garbage collection. The unused objects in the memory are removed automatically. The programmer need not explicitly write code for removing the objects or allocating and deallocating memory. There is no direct accessible pointers to memory. Simplified network access, supports multi-threading and has robust exception handling. Java Virtual Machine, or we call it the JVM. The .class files generated by the compiler are not executable binaries. Instead, they contain bytecodes to be executed by the Java Virtual Machine. This approach provides platform independence and greater security. The process is in this fashion. We use an editor. All you require is a notepad for editing or writing the code and saving it in the hard disk as a .java file. The compiler creates the bytecode and again writes it into the hard disk. During runtime, the class loader reads the .class file and loads into memory. A bytecode verifier confirms that the bytecodes are valid and do not violate Java security specs. The Java Virtual Machine reads the bytecode and translates them into language the computer can understand. Java stack and heap. All the objects are created in the heap. The variables or the references to the objects are stored in the stack. To start with Java, download the Java SE from Oracle site. For example, JDK 7U55 for Windows. It's an executable file. Install the JDK and set the environment path. On the DOS prompt, test javac and Java. To set the path, locate where the bin folder of the JDK is there. For example, C program files Java JDK 1.6.0 bin, and add it in the system variable of your machine. Look at the first program. Create a file called myfirst.java. Type in the code. It looked like this: public class myfirst, and we have a method public static void main with parameters string array, and give it a variable args and system.out.println in double quotes. Pass the argument myfirst.program, which prints my first program onto the console. To compile it, javac myfirst.java, and to run it, Java myfirst, and you will see the output myfirst program. To set the environment variable, go to edit the system environment variable, environment variables, and select Java_home, and you can see this is where I have installed the JDK. You can check it and see I have program files, under that Java, under that JDK 1.7. so you can see this is the path. Once that is done, edit the path and then add it here, %Java_home and the bin. So now I have set the bin folder to the path of my system. So you can see here Java is there, javac is there, which we require for compiling and running the program. So this is my project folder where I am going to create my class. So as we saw, I'll create my first program, my first.java. So I'll create it here. I'll use Notepad as a editor. Public class my first so class is there. Now I'll add the method public static void main string args system dot out dot println my first program, save it. So I can see the Java file here. I'll compile it. Java C my first .java. It's compiled and you can see my first .class there. To run it, Java my first you can see the output my first program. Now let me create an object. First I create a class, say car.java, public class car. I'll have a field called string type, make it private, ensures encapsulation, give it a setter, it's a void method, set type, pass a string type here. I need to set the type of this car, that is an instance variable which is type with the value which has come in as an argument into this method. So to access this type, which is the instance variable, I'll use this dot type equals type. So this method is an API through which I can set the value of type. I need to use a getter now. Public string, it returns a string type, get type which returns type. So my object is ready. I'll use it here. Car C is equal to new car, and I'll use the method C dot set type body, for example, Now I'll check it. To check it, I'll put a sysout. My car is, concatenate that, c dot get type. I'll recompile it. It automatically compiles car because there is a reference of car in my program. And I'll run it. As we can see, my car is Audi. So what we have done is, we have set the type of the car to Audi and we are trying to get the type of the car. I could do that with an object of, say, bus. Public class bus. Okay, I can have similar code in that. And I can use this bus b is equal to new bus b dot set type Volvo print it. Bus is a bus dot get type. Again compile. Bus get compile automatically. This is Volvo. But if you look at the code, we are repeating the code here. Instead of that, we could use inheritance to avoid repetition of code. So I'll put a class vehicle public class vehicle and put the code there. I'll transfer the code to vehicle. And I'll make the car a subclass of vehicle. By saying extends vehicle. Same with the bus. Extends vehicle and remove this. Save all the programs. It makes no difference to the output. So this is a parent and these are the children. And this is called inheritance. there is a possibility that you may make a object of vehicle and it compiles to, but I can prevent someone making an object of vehicle by putting restriction here. I make this vehicle as abstract. Now it will not compile, cannot be instantiated, so I cannot do this. The reason I am preventing somebody from making an object of vehicle is that in the real scenario I can see an object of car, an object of bus, truck, bike, but there is no object of vehicle on the road. So the vehicle is actually in fact abstract. So that is what is meant by abstract. You cannot make an instance of vehicle.